Hello, my name is Jason Brickner with Olympus Controls. Today I'm going to show you the Yaskawa Sigma 5 drive with Ethernet IP daughter card connected to an Allen Bradley CompactLogix controller and a Parker CTC IntractXpress HMI. The setup I'll be showing today features a Yaskawa Sigma 5 servo drive with Ethernet IP daughter card. That's connected via Ethernet to a standard Ethernet switch, which also has connected an Allen Bradley Rockwell Automation CompactLogix L23E and a Parker IntractXpress HMI. I also have a programming PC set up. The HMI allows me to enable and disable the servo motor and drive, clear any faults, home the motor, now we'll take a little deeper look under the hood to see how all these components interact together. We have the Parker IntractXpress HMI screen here, where we already demonstrated that we could reset drive faults, enable the drive, jog the drive forward and reverse, send the drive to a specific position. If we go out of the runtime mode and go into development mode, we'll see that the HMI is made up of several buttons, numeric displays, and whatnot. Those numeric displays are tied to tags like this here. These tags were all imported from the PLC, from the Allen Bradley PLC, through the communication driver. If I look at my communication driver, I see that the Parker IntractXpress HMI is able to browse all of the tags inside of the CompactLogix PLC, and from there I can import them into my tag database and then connect them to various buttons and displays and alarms inside of the project. When I manipulate the buttons and displays and numeric entries in the HMI, it changes the values in their ladder logic program. If I open up my RSLogix 5000 programming software, I see that I have a Yaskawa sample project preloaded and running inside the PLC. You'll also notice there is a servo drive module mapped under the Ethernet port of the PLC. There's the Ethernet IP address of the servo drive, and I see the running routine where the drive is configured. There's a heartbeat, there's access status bits, the servo is on and servo is ready. And then here's some of the instructions you might be used to seeing with Allen Bradley's motion setup. There's servo on, servo off, access stop, fault reset. These are all similar names to the Rockwell motion blocks. Here's a axis move, different types of motion, absolute, relative. There's blended moves, there's jogs, homes, gearing instructions, camming instructions, blended move instructions, sequence instructions, sequencer, edit instructions, torque control, and programmable limit switch functions. You'll also see that Yaskawa provides a whole set of add-on instructions. everything from blended moves to motion configuration instructions. There's also user-defined data types that go along with the drive. And if I look up under controller tags, you'll see there's already an axis that's defined. And you'll see things like torque feedback, speed feedback, acceleration, speed, move times, servo status, etc. When I interact with the controls on the Parker HMI, it controls the bits inside of the program running here, which in turn controls the servo drive. And that's how it works in a nutshell. Next, we'll dig into what it takes to take these devices new out of the box and get them up and running. The first step in the process of commissioning a new system is to take the Yaskawa Drive, hook it up to power, connect the motor, cables, and connect the Ethernet cable, and then launch a software configuration utility called LogicWorks and create a new project. And this is kind of a wizardized setup tool to allow you to configure the Sigma 5 drive with Ethernet IP and commission it for working with the Rockwell CompactLogix or ControlLogix PLC. It's user-friendly, lightweight, easy to use. You kind of start from the left and work your way to the right, going through each tab. You can open, save as, previous configurations. You can get connected to the drive. I've already changed the IP address of this drive, but you would use the default address that comes with the drive, and you could ping it, get connected to it. Once you get connected, then you could upload a configuration if there was already one in there. But since this is new from out of the box, if you had a configuration already set up, you could download it here, or you could just go through the configuration process. So again, step number 2, then I have these tabs here I just work through. First thing is, do I want to change the Ethernet IP addresses for port 1 and port 2 and give it a gateway address. Then I can come in and set up my scaling, because the PLC is going to tell the motor to move in millimeters or degrees or revs or feet, inches, meters, or some user-defined type. That simplifies the programming in the PLC, but I need to set that up in the drive here. So if I've got a gearbox or a pulley setup that has some gear reduction, I can put in the gear ratio there. If I have a ball screw or some other kind of feeding device, how many inches or millimeters per revolution do I have? There's some nice help files and examples to walk you through that. And then I have the ability to configure my hardware limits, my over travel limits. I can set up torque limits on the drive, the position error window, the settling time, the power settings, regen settings, dynamic braking, the encoder settings if I want to use the absolute settings, what direction is forward and reverse with regards to the rotation of the motor. And then Yaskawa's tuning is very good. You can set several different levels of tuning from rigid to loose, and that's it. You don't need to configure any P, I, and Ds. This is a real strength of Yaskawa. If I want, I can use their Sigma Win software, which is a real high-end configuration and PID tuning utility that lets you get into all the nuts and bolts of the drive and use an oscilloscope to tune and get things tighter. But typically it's not required. You can even have a system with up to a 20-to-1 inertia mismatch with the load, the rotor to load inertia ratio of 20 to 1, just using the built-in tuning that's in the auto tuning inside the drive. If you have an external encoder that you're going to do gearing or camming or following on, you can set that up here. You can reboot the drive here, and you can also update the firmware from here too. So that configures the axis, that configures the drive. Now the next thing we can do is the drive is capable of having, I believe it's 200 index steps, and they call these steps sequences. And what a sequence looks like, here's sequence number 1 could be a move, could be a jog, could be a blended move, could be an absolute move, and at various acceleration, decel, speed, go to a position, registration move. You have some options of what you want to do before the move, what you want to do after the move. You can delay, wait, then do the next move. You can even do some sophisticated branching. But you set up all these sequence steps here, and then your PLC can call what step in the sequence it wants to run. So if you didn't want to use the Yaskawa motion instructions, then you could just send it you could use the Yaskawa sequence instruction, and you could just tell it to go to these different sequences, which are different moves. Either way works just fine. Then the next tab in the configuration window is a handy utility that allows you to enable and disable the drive and jog the drive forward, reverse, different accelerations, decels, velocities. You can even move to a specific position. You can set the encoder. This is an absolute encoder in here, so you could set the 0 position by pushing this button. And then also you have feedback about where the motor is and what speed is, if there's any alarms. The other part of this test run is you can run parts of your sequence, your index table here, your sequence table. And you can step through it sequence by sequence. And then the last tab here is a monitor tab. So this will show you active alarms, the last several alarms in the alarm history. You can clear alarms. You can also monitor your sequence position, any of your inputs and outputs, also the current position, torque, and then where you're at in the sequence. Nice little monitoring tool. So anyways, after you configure your axes, after you configure your sequence, then you come in and you do a download. And by clicking this button here, I can download the axis configuration and the sequence table. And after I push that download, it will go through a reboot sequence, and then I'll be brought back to this screen here where I can reconnect and monitor. But from that point on, you're finished configuring the drive. There's nothing else you need to do to the drive to get it to talk via Ethernet IP to the Rockwell PLC. One last thing to show here is that you can save this configuration. You can have multiple configurations saved all through this utility here. It's really nice, simple, and so now the drive's ready to talk with the PLC. So we take the CompactLogix or the control logics out of the box, get it connected to power, connect its Ethernet IP, its Ethernet connection to the switch where the Yaskawa Drive is connected, and open up our RSLogix 5000 programming software. You'll want to configure you want to get connected to to the PLC and configure its Ethernet IP address. And then once you do that, then you can come and open up the sample program, the sample RSLogix 5000 program that comes with the Yaskawa Ethernet IP drive. So I'm going to open that up in offline mode. You'll see this is the same program that we were looking at before. Kind of lets you do kind of everything that is possible with the drive: jogging, moving, indexing, sequencing. The sample program also has all of the add-on instructions already added, and the user-defined data types for the Yaskawa Drive. It also has one Ethernet IP drive mapped into the I/O configuration. So the first thing you want to do once you open up this sample program offline is you want to go into the I/O configuration, and you want to drill down into the CompactLogix, into the Ethernet port, and you'll want to find that drive, that Yaskawa drive. It should be mapped in here. You want to double click on it, and that'll open up the configuration utility for the drive. I would just leave the name. See the description they've already given it. And then what you'll need to change is the IP address of the drive. That way the PLC can find the drive out on the network. And so mine is already set. Leave everything else default, don't change any of that. And then click OK. That's the only thing you need to change in this program to get it out of the box and get it up and running and talking with the Sigma 5 drive, the Yaskawa drive. So we've changed that. Let's go ahead and download this to the PLC. Click on Communications, Who Active. This will go out and scan the network for any Rockwell PLCs, and I see there is my PLC there, and its backplane, and there is the processor, the CompactLogix processor. So I'm going to click on Download, and that's going to download this PLC program to the brand new PLC. Once it's downloaded, it's probably going to ask me if I want to switch to remote run mode. I'll say yes. And now my PLC program is running, and the first thing you'll notice is that it's already connected to the Yaskawa drive. It's got a heartbeat going on. If I wanted to, I could, the servo is not on right now, I could come down here and toggle it on. I click Control T. I just need a one-shot toggle of that servo on, and you'll see now that the status is that the servo is ready and that the servo is on. So that's it. All I had to do was open this sample program, change the IP address of the drive, and then download it to the PLC. And I'm connected, I'm talking. I can come down here and take it out of auto mode and put it into, scroll down just a little bit more, put it into manual mode, Control T. That turns on manual mode, and now I can toggle that, jog forward, and I see the motor moving forward, and I can jog reverse. Take it out of manual mode, and I can go scroll up, and you'll see there's an auto mode right up here. If I toggle that, now I can execute a move home, and I can move forward 200 millimeters, and there's quite a few other move instructions in there. There's also sequence move to a specific sequence. So run the sequence. We saw that in the previous configuration. So that's it. The PLC is now talking to the Yaskawa Drive. So if we do have an HMI, which we do in this system, we have the Parker HMI HMI, then we need to configure an HMI project to connect to the PLC. And that allows us to toggle bits on and off, change values in the PLC. Those values are the accelerations, the velocities, the distances that we want to move, maybe the sequence that we want to run. It also lets us monitor things like what's the how much torque is the motor producing, and how close is it to overload, and are there any alarms, and what position is it in. So once we take the IntractXpress box out of the box and we get it powered up, we'll assign it an Ethernet IP address, and then we'll open up a software package called IntractXpress Manager. When we open it up, we get a screen like this, and it shows us if we have any local projects on our PC, and then it'll show us if we have any remote machines out on the network. This is where we could change the IP address or update the firmware of the hardware out there. And then eventually you'll see where we take a project that we've developed it and move it onto a machine that's out on the network by pressing the send button. But right now we need to create a new project. Let's just give it a name, Yaskawa 2. This will go and create a new project file. The first thing we need to do is connect it to our PLC. Right now the HMI doesn't know what PLCs are out in the field. We just have one. So we click on the Comms tab. We add a channel. You can think of a channel as a network, whether that's Ethernet, EtherCAT, Ethernet IP, Modbus TCP. Just going to call this one EIP for Ethernet IP. The device driver we want to use is the CompactLogix Ethernet driver. We want to enable diagnostics, and then we'll go back here. The network adapter, I like to specifically select my wired network adapter that is connected to this PLC, and then accept the default settings. Click Finish. Underneath that network, that Ethernet IP network, we're going to add a device. This could be one or more. Sorry, this is one PLC, but we could add multiple PLCs to the network. I'm just going to call this CLogix, and it's not a ControlLogix. Our demo is a CompactLogix 5300. Click Next. And the device ID can be a little bit tricky. What it consists of is the Ethernet IP address, which is 192.168.100.10. Then a comma. The next bit of information is the next path, which is the backplane. And for Allen Bradley, the next number is a 1. And then since our CPU is in slot 0, with the CompactLogix there are no slots for the CPU to plug into, so the CPU is in slot 0. So IP address, comma 1, comma 0 for this CompactLogix. Hit Next and just accept the defaults. And then click Finish. So now we have a CompactLogix set up on an Ethernet IP network. If we had more PLCs, we just continue to add them here by right mouse clicking in New Device. Okay, one thing we want to do is we want the communication driver to go out and connect to the PLC and pull in any tags that are inside of it. So we do that by right mouse clicking on the device, clicking on Properties, going to Database Creation, and then click the Auto Create button. you'll notice that a plus sign will appear next to the device up here, signifying that it's gone and connected to the PLC and uploaded all of the tags that are inside of it. If I click this plus sign here, you'll see it's got lots of different groups of tags now that we can import into our project. Right now they're just in the communication driver. Okay, that's it. Communications are set up. Now we need to set up our screens and our buttons and numeric displays. So I click on the Shell tab and I click on Design. This is going to allow me to create new panels, import tags, set up alarms, messages, recipes. Let's go ahead and create a new panel. And let's call this panel Yaskawa. Now I've got a blank slate to work with. I have a whole bunch of tools down here that I can insert onto this display. I'm just going to go ahead and grab a push button and drag it and drop it up onto the screen. And I'm going to use this push button. I'm going to change its appearance and the off lens. I'm going to edit the text. And I'm going to call this servo on. And the on state will be servo is on. Okay. I can do a test run and I can look and see what this button looks like in runtime mode. Okay. Now I need to connect this button to the PLC so that when I push this button it changes the bit in the PLC that enables the Yaskawa Drive. The type of button is just momentary. The PLC ladder logic is written in such a way that it just needs a momentary toggle of that servo on bit for it to enable the servo drive. That servo on instruction works exactly like the Allen Bradley servo on instruction. Okay, so in order to do that, I need to connect this switch input to a tag. And if I look here, I don't have any tags from my PLC yet. These are internal system tags from IntractXpress. So I'm going to have to import in some tags first. I'm looking for a tag called A1PB servo on. If I click on the Tags tab and then I click on the Import selection, it's going to go out and read the communication driver. And the communication driver, remember, it imported all those tags into its database, and now it's showing, hey, here's a whole list of items of controller tags inside the PLC. Which of these do you want to bring into your IntractXpress project? I'm going to go down here to my A1 config, and that has the servo on. That's not right, actually. Here we go. No, not that one. Okay, I found the tag that I'm looking for. It's under EIP CompactLogix Global Tags. And I'm going to go ahead, the one I'm looking for in there was servo on, PB servo on, so you'll see it here. PB, there's my jog forward, jog reverse, servo off, servo on. I'm just going to go ahead and grab all of these and I'm going to import them into my project. Now that we have our tags imported into the project, we can go back to our panel and we can go back to our push button and we can connect it to the tag. So the switch input now is going to be connected to the push button, servo on. Every time we push the button, it will turn that bit on. Every time we let go, it will turn that bit off. I want to also change the appearance. I want the off state to say servo on. And I want the next state, when the servo is on, I want it to display servo is on. Now, I have the ability with a push button to not only give it a switch input, which reacts to the operation, if I'm pushing the button in or letting the button out, but I can also change the status of what the lens is displaying. So I want to monitor if the servo is actually enabled, the feedback from the servo saying that it is now on. And there is a tag called axis servo on. And if I monitor that, then it should show me when I push the button, if the servo actually comes on, then I'll see this button stay lit up green saying servo is on. One of the neat things about IntractXpress is that I can actually run this project from my PC before I ever download it to the actual IntractXpress hardware, the touch panel. I can do that by clicking on Home and then clicking on Connect and Run. And now if I push this button, I hear the servo click and enable and start servoing, and the servo is on. Now, one thing I forgot to do was add a button to this screen so that I could exit out of that run mode. So what I had to do was close my project and reopen it and go back into this panel. So before I do anything else, I want to add a push button down here in the corner that allows me to exit my test mode, exit the project. So this button type will be exit, and we might as well change the appearance to also say exit. Okay. So we've got the on button working. Let's add an off button. Let's just go ahead and copy this and paste it. We'll put one right next to it. Let's change the appearance when the servo is off. Then let's go ahead and say, let's make this button say turn servo. Let's have it say servo is off. So when the servo is not on, this will display servo is off. And let's make it like a bright red color. Actually, let's make it dull red. Servo is off. Oh, change my mind. Let's make it bright red. Okay, and then the next state is when the servo is on, we want this button to say servo off. This will give the operator the ability to turn off the servo. Okay. And then we better check our values and go to the switch input. Now we want this to be the servo off tag. So when we push that button, it will turn the servo off. Alright, let's go ahead and test run this now by clicking Home, Connect, and Run. So the servo is indeed on right now. If I click this button, turn the servo off. Click this button, it turned it on. So now I can turn the servo on and off. Now I'd like to add one more button to put it in manual mode, and a button to jog it forward, and a button to jog it in reverse. So let's do that now. So I exited out of my runtime mode and I'm back in the design mode. I'm going to add another button here. In this one, I'm going to make a maintained button. So when I push it, it will hold it in and maintain the manual mode, and when I push it again, it will uncheck, it will unlatch, and will not be maintained, and it will make that manual mode bit 0, so I can switch in between manual mode and on and manual mode off. So let's go ahead and I'll change the appearance and make it yellow now. And on. Okay. And then once I push it in, manual mode will be enabled, so I'll do manual mode on. Manual is on. And let's make that bright yellow with a black font. Okay, so that should allow me to turn on and off manual mode. Let's go ahead and connect that to my manual mode tag. So there's my manual mode tag. Okay, that should be good. Now we might as well add the jog forward and jog reverse buttons right now. Let's go ahead and add another push button up here. Change this to jog forward. Might as well make this also say jog forward. And the value for the switch input is going to be our jog forward tag. Oops. That one is called A1PB jog forward right there. Alright, and let's go ahead and make a jog reverse while we're at it. Just copy and paste that and change the appearance. Okay, and we'll also want to change this switch input to be jog reverse. There should be a tag already in there for, there it is right there, jog reverse. Okay, let's try this out. Connect and run. Okay, so the servo is off right now. Let's turn it on, and let's turn on the manual. And when I jog forward, I see it turning forward. When I do jog reverse, I see it turning the other way. Let's do one more thing and put a position feedback on the screen, and then we'll be done with this. Exit out. Disconnect. Go back to design mode. Go back to our panel. This time let's add a numeric display right down here. And let's put a header up there. To explain that this is position. Let's do actual position. And we'll get that lined up there. Now let's just connect this to the tag that shows our position feedback. And I don't yet have that tag, so let's go back to our tag tab, import, and that's right under here. And here's our position feedback. Let's just select all those and import them in. Okay, go back to our panel now. Go back to actual position. I'm going to change the appearance of this, and let's give it a few more characters and another decimal place. And now let's connect it to our position feedback tag. It should be position feedback right there. Okay, now let's run this. And we're now getting actual position feedback. So our servo is still on. Let's turn on manual mode and let's jog it. And we can see that it is moving the motor, and I do see the shaft turning and the positions changing. So that's it. Now the project is complete. Let's disconnect, go back to design mode. And once our HMI project is all complete, we might have multiple panels in here. We might set up alarming in that, and we'll do that at another time. But I see that my Yaskawa 2 project is right here, and my IntractXpress panel is over here. I simply click send, the send button, and it says, are you sure you want to copy? Or sorry, you must close this current project, which is also going to save it, and then it will copy this project over to the actual touch panel. So I log in with my admin, username, password is blank, and I hit send. Yes, I want to send all parts of the project over. Oop, I spelled my password wrong here. Try it again. There we go. It will transfer the project. The project will show up on the touch screen, and just push the run button on the touch screen, and now that project will run with the touch screen. And that pretty much completes everything. I have a more advanced HMI project for the Yaskawa Drive, and it is called Yaskawa Ethernet IP Demo. So I'll show you next how to take that. Essentially, it's the same process as what we just did. If you didn't want to create your own HMI project, you could simply take the Yaskawa Ethernet IP demo for the Parker HMI HMI, and you could select that. If it's not in your local project folder, then you could go and browse. Sorry. You actually have to have the project in your local IntractXpress folder. You can change that default folder by going up to the local project path and changing that. So that way it would look for local projects in a different file location. Once you see it listed, then you simply highlight it and then highlight the IntractXpress panel that's out on the network, and then click the send button, and you'd want to type in your username of admin, blank password, and then send complete project. Hit send and say yes to all. Now it'll transfer that Yaskawa Ethernet IP demo project over to the touch screen. It'll reboot itself and then be ready to run.